This video briefly explains how to apply the conservation of energy, or how to convert kinetic to potential energy, or from potential energy to kinetic, as it states over there. So let's say I have this very simple contraption called a ramp, and an object with a mass m is placed at the top, and let's call this as our initial point. So let's call this as the initial point, where I represents initial. So our initial point. So it does have mass. So the mass is represented by the small letter m, or lowercase m. And two types of energy that we have right here is the potential energy and the kinetic energy. So basically, we have both potential and kinetic. So it depends on the state of the motion of an object, or the position of an object. You might have potential energy but no kinetic energy, or you might have kinetic energy but without potential energy, or you might have both. Maybe both object might be moving and at the same time possess a position above a certain point. And before we proceed on with concept of potential and kinetic, let's say that the lowest part, so this is the lowest part of our ramp, considered as, let's call it level 0. Level 0, because this means that at this position, the height is 0. Okay, height is 0. While at this point, we have noticed that it's not at 0 anymore, but since it is the highest point of the ramp, we can just call it as its height maximum, or h. Okay, so height. Now, in order to get the total energy, all we have to do is add the kinetic and potential. So basically, the total energy is just the sum of potential plus the kinetic energy. And since this point is considered initial, so I would say that this is the initial total energy, the initial potential energy, and the initial kinetic energy. So you just have to add them all in order to figure out the total energy. Now, we might have different points in this situation. Maybe I can call this one as point letter A. This one is point letter A, point letter B, point letter C, and of course the last one is point letter D. Point letter D, in this case, I can consider this as my final. So we can also call it final, F. So F represents final. So it means this is the final position or final point along the ramp, or along the contraption. In our case, this is a ramp. Again, just like the initial point, we have both the potential. We must consider both potential and kinetic energy. And the total energy at this point is also the sum of the potential and the kinetic energy. Potential and kinetic, but it is the final position, so we can say that this is your final total energy is equivalent to the sum of the final potential and kinetic energy. In some cases, you will be required to solve for velocity, you are required to solve for mass, or mass is not really that much of an importance in terms of conversion of energy. However, you might be solving for velocity and at the same time the height. So in some cases, you might be asked to solve for what is the velocity at each point. For example, what is the velocity at point A? What is the velocity at point B? What is the velocity at point C? And what is the velocity at point D? So this might be some questions that you will be asked. Knowing what is the height, you will be solving for any of those given information. Let me just pause the video, and so you can copy down the rest as we proceed with the next part. Now, as we continue, here in this scenario, okay, let me just select point B. Okay, so point B, let's say point B is basically halfway, which is h over 2, so halfway. So if this is your total height, B is considered as halfway. So we can say that the potential energy at point B and the potential and the kinetic energy at point B. So we can also figure out that this total energy at point B is also the potential energy at point B plus the kinetic energy at point B. Things that we must remember, according to our previous lesson or previous video, the total energy, TE, or total energy, remains constant throughout the system. So it means that the total energy initial is equal to the total energy at your final position. So the sum, the total kinetic energy, or total energy, both potential and kinetic, should be equal, should be the same. This also means that the total energy at point A is the same as total energy at point B. Total energy, or it is also equivalent to total energy, that is equivalent total energy at point C, and also equivalent to total energy at point D. Now, what happens in that case? Okay? If you notice, at this point, let's say it doesn't move yet, however, you do have height, so therefore we can consider that there is another form of energy aside from kinetic energy, and that's called potential energy. So let us write some reminders. Second one, okay, if you lose loss in height. So when you lose height, for example, from the initial point to point A or to point B, the height is becoming lower. Okay? So as you decrease the height, okay, this means loss in height means there is a gain in speed. There's a gain in speed. Okay? As you go to the bottom of the ramp, it increases speed. Likewise, loss in speed means gain in height. So it means what if it's going to be an opposite direction. So from here, so let's say it starts with a high speed. As it goes up, it will slow down until eventually it will stop. And so anything that you gain in height is equivalent to an increase in or decrease in speed. So what does it mean? What does it tell us? So we can say that the total energy at any given point, let's start with the initial velocity or initial position, is equivalent to the total energy at the final point or any given point. So from here to here, you have the same total energy, but just for the sake of comparison, let's figure out this point to this point. So what does it mean? Okay. So this means that the potential energy initial, which is equivalent to mg times height initial plus the kinetic energy initial, is equivalent to 1/2 mass VI squared. So you add these two values, then you will have total energy, and that sum should be the same as the sum at the other end of our equation, which means the potential energy at the final position should be the same as mg h final plus the kinetic energy final is equivalent to 1/2 mvf squared. Now, further, let us put some values. Let's make the assumption that at this point, the initial velocity is set to be at 0. So I am placing this marble or a round object on top of the ramp, and I will let it slide. I will let it slide. And you want to figure out the velocity at point D. So how can we figure out the velocity at point D? Simple. Okay. First part is, let me just highlight that we're trying to figure out the final velocity, and the initial velocity is set to be at 0. So initial velocity or initial position, let's apply this. So we all know at initial condition, velocity initial is set at 0, while the height initial is equivalent to h. Now if you look at the final position, final condition, you notice there's no more height because it is at the lowest point where h is 0. So let's put h final is 0. Now we want to solve for the final velocity. Okay, so we want to solve for the final velocity. Just plug in the values. So let's say potential energy initial, which is mass multiplied by g, and then height hi is just simply h, and then let's add the kinetic energy initial, which is 1/2 mass times the initial velocity, which is 0 squared. So this means that this value is simply equivalent to 0. So all we have to do is add these two values together. So it means we have mgh plus 0 is simply equivalent to mgh. So this is our total energy initial. A total energy initial. Now, let us calculate our final conditions. So we have potential energy at final is mass times g, and we all know that the position is already at the lowest point, so our height is set to be 0. And this is 0. Plus the kinetic energy at your final position, which is m, or 1/2 m v of d, and then you square it. If you add this two, then we have the total energy at final position is equivalent to 0 plus 1/2 mvd squared equals just 1/2 mvd squared. By equating these two, because they are equal to each other, since they are equal to each other, we can further solve for its value. That is, change color pen, mgh equals 1/2 mvd squared, where we can cancel our m, divide both sides by m. So now what's left is gh and vd squared and 1/2. In order to get rid of 2, you multiply it to both sides of the equation. So we can say 2GH is equivalent to VD squared. But we don't want to solve for just VD squared. We want to solve for VD by means of taking the square root of both sides of the equation. So therefore, we can say that our value is VD equivalent to the square root of 2G and H. In the next video, you will see an example where actually there are some values in it.